And welcome back to today's question. Now, a nice question today. I mean, I tend to say that most days, but this is a really good question to show you 3 different tips to how to solve these sorts of questions. And it's not, it may be one that some of you haven't seen before. And frankly, some of you may just look at this question and just not know what to do at all. But as I say, you're going to learn 3 different techniques which will help you with these general sort of Olympiad competition style questions. So if you've seen them before, well done. Good luck. Let's see if we get the same answer. If you haven't, give it a go anyway. Let's see where we get to, and I'll come back in a couple of minutes and show you how I thought about this question. Okay, so how did we do? As discussed, some of you may not know even where to start with this, so there is a bit of just learning techniques here. So just to not really add much value at all, I'm just going to write down the question at the top, or write down the sum at the top. So A equals an infinite sum and B equals an infinite slightly different sum. What could I do? Well, in this case, because I've got the square root of something, at least to do something, I could square both sides. So on the left-hand side, I've got a squared equals, and now if I'm doing the square of a square root, the square root is going to go away, and that leaves me with a squared equals 2007 plus, notably, another infinite sum. Do the same with a b, so b squared is equal to 2007 minus something, which again is another infinite sum. The key to this first part of the question, so sort of technique 1 if you like, is I need to notice that these 2 things here are not just an infinite sum, it is the same infinite sum that I started with. So in other words, the thing on the left is A and the thing on the right is B. Again, if you're not quite sure, take a minute, make sure you're okay with that, because it's an important technique that you'll use every now and then if you sort of do some higher level maths. This actually means I can write the left-hand equation as a squared is equal to 2007 plus a, and I can write the right-hand equation as b squared equals 2007 minus b. And that's giving me 2 equations. Now, as with all of these sort of questions, what am I trying to get to? Always have that in the back of your mind. So I want to get to a minus b. So then my next step is I'm going to do a squared, or I'm going to do equation 1 minus equation 2, which is going to give me a squared minus b squared equals 2007 minus 2007, which goes away, and a minus minus b, which is a plus b, which gives me a plus b. Now, I actually did something there without really explaining why I was doing it. So there's an element here of just experience and knowing what's going to happen. And I know 2 things. So I know firstly that on the left-hand side, I have difference of 2 squares. So that's going to tell me the left-hand side is a minus b, a plus b, and that equals the right-hand side, which I've added brackets intentionally, which is equal to a plus b. And so technique 2 is to use the idea of difference of 2 squares or squares in order to help me get somewhere, which leads to technique 3, which is understanding that if I have a number multiplied by another number, so let's say x times y, and I end up with y, well, the x value, or in this case the a minus b value, can only be equal to 1. So it must be true, remember what I'm trying to show here, it must be true that a minus b is 1. Now that's not great, it's not the most rigorous of proofs, so let's actually do that algebraically. So what I could do is I could, as I've done here, is I could bring the a plus b on the right hand side over to the left hand side, factorize it out, and that's going to give me a plus b times a minus b minus 1 is equal to 0. Now I know that a plus b isn't 0, because I know from the question that a is a number. I don't know what that number is, but it's definitely a positive number. And b is definitely a positive number. So therefore a plus b can't be 0. So it must be the case that a minus b minus 1 is 0, or in other words, I must be able to say, and it's kind of what I've just said there, I must be able to say that a minus b is equal to 1. Again, quite a few different useful techniques going on there, but the point is, with rigor, mathematically, I have proven that a minus b is equal to 1. So that's the first part of the question done. Next part, and I'm going to clean this up, I'm just going to move the main bits over. So this is from the previous page. Hopefully we're all okay with the idea that a squared equals 2007 plus a, again equation 2, and from part 1, a minus b is equal to 1. Now, a times b, if we think about when I want to create an a times b, there's a few ways I can do that, but one way I could do that is I could do a plus b all squared. Because if I do a plus b all squared, I get a squared plus b squared, which I have in equation 1 and equation 2, and then I also create a 2ab. So why don't I first of all just add these 2 equations and keep that idea in the back of my mind. So I'm going to add equation 1 and equation 2. Remember in the previous step, I took these equations away. Now I'm going to add them together. So I've got 1 plus 2 tells me that a squared plus b squared equals 2007 times 2 plus a minus b. Now remember from up here, I did this in part 1. I know a minus b is 1, so therefore this a minus b here must be equal to 1. It must therefore be the case that a squared plus b squared is equal to 4015. Now remember what I said. Technique 3, I think I'm on 3 or 4, whichever technique I'm on. Technique 3, I need to create an a times b. And I've got an a squared and a b squared, but what might be helpful is if I had an a plus b all squared. Now, why did I do it that way around? The reason I've done a minus b all squared and not a plus b all squared is because I know what a minus b is. I know a minus b from part 1 is 1. Had I used a plus b all squared, well, I don't know what a plus b is, so it wouldn't have taken me any further. So I've used what I've got in part A in order to help with part B. So now I'm going to use this. I've rearranged it for the second equation down here. So I know that a plus b squared is a minus b all squared plus 2ab. I can substitute that into my first equation, and that's going to tell me that a minus b, which is 1, all squared plus 2ab is 4015. Take away 1 from both sides, 2ab is 4014, and that ultimately tells you that a times b is 2007. Not an easy question, but a really nice question to introduce some techniques that we can use in these Olympiad mathematical competition type exercises. They come up a lot in different ways. And I say this question kind of covers a lot in one go. So if you didn't get there, especially if you didn't get there first time, go through it again, make sure you're okay with it. There is another question coming up soon, which will lean on these techniques another bit. If you got there, well done. Again, difficult question. As ever, like and subscribe. Got a bit more algebra coming this week. And we've also got a couple of logic questions as well, just as a sort of light, different sort of idea. Any comments, please do leave in the comment box or I'll get back to you. See you all again tomorrow. Thanks all.